Good evening to everybody. Today, our on behalf of IEI Tamil Nadu State Center, we are welcome today's speaker Jayakrishnan Rajagopalan. He is AVP Global Solutions, Ramco Systems. Now, the today topic is artificial intelligence in IoT. And then now, Engineer P.S.P. Praveen will introduce today's speaker Jayakrishnan Rajagopalan. Now, Praveen, take over that. Praveen.
Thank you, Chairman Ramdas, sir. I have privilege to introduce Jayakrishnan Rajagopalan. He's a fantastic, down-to-earth, what you call technology person, and I found him in my blockchain times, and he's a fantastic blockchain coder, and he's developed a blockchain exchange product, and which is now commercial and it is running in Middle East. And very few blockchain projects are in implementation. And Jay Krishnan's, I call him Jack most of the time. His product is running production for almost like 3 years now, and now he is working with Ramco Software Systems, Chennai, and he is working on all new initiatives of Ramco Global. It's my pleasure to introduce my friend Jayakrishnan Rajagopalan. Jack, for you.
Thank you so much, Praveen and Mr. Ramdas. It's really a privilege to be called again. My audio is right for the forum, or
yeah, it's good.
So I don't want to add much about myself. Just one thing is that I'm also a student, which Praveen knows, but he has not put it out. Whatever I am in my experience, I'm now still pursuing my PhD in what we call as adaptive neural networks. So without much ado, today the topic that I am trying to share my knowledge is in the space of artificial intelligence, machine learning, IoT, and I will slightly touch upon my favorite subject, blockchain, also in one of those slides. Any questions, anything, you can put it to the forum on the chat session. We'll do it at the end of it if it's to be responded, or we can always connect offline and continue discussions. Okay? Slides. Let me set the context. If it's to be responded or offline and continue discussion. Sorry, was that a question to me?
No, sir, you continue the question and all. End of the session will have a question.
Perfect. Okay. So the coverage we have for today's session from my side is about what to be able to share this knowledge with you. Nowadays, there is nothing called what the customer requirements are. Rather, it's about the customer's desire. The days of meeting the customer demands are gone. We're actually trying to go to the next stage of understanding what the customer is wishing for, the desire aspect. I'll touch upon very top level what is IoT and what is the AI per se, and the common world that they live in, and why they should collaborate AI and IoT per se. I'll also share a couple of use cases which are in Ramco Systems we have delivered to our customers. In addition to that, I'll also share and speak upon some of the global use case models, which by itself IoT would not have actually matured, but with the collaboration of either machine learning or intelligence from a data system or anything to do with data lakes, combination of that, how those use cases are now getting fructified or getting utilized in the global markets. So some of the materials as disclaimers which I've used, books, references, in addition to the research lab from Ramco Systems per se. So what you're seeing at the starting of our presentation is basically what is the purpose of IoT at the end of the day, right? I mean, I am not an engineer, as a disclaimer. You are mostly, all of you are engineers per se, and there is always a purpose when you design a system. more so a device, right, or a sensor, or anything for that matter. At the end of the day, the purpose of that is to sense something and to alert an audience. Could be anybody, it even could be another device or another system for that matter. But at the end of the day, everything is to do is finally coming down to increasing the productivity. It could be to reducing waste from very old days where there was a simple system where you could send SMS to stop a water pump in a distant field, or increasing efficiency to the point where SCADA devices used to ensure that when there was a certain thermal output, heat generated or heat sensed, it shuts down or cools down, or certain steps were taken to ensure that the efficiency was increased by certain steps. Uh, in the same follow-up reduced downtime, the more and more the wear and tear of any device is small or big for that matter, keep a tab of it, look at what their performance levels are, and when the performance level goes down from a threshold perspective, automatically to be able to send out a requirement for downtime. And in 24/7 industries, downtime means there has to be adaptive systems or fallback systems which has to be prepped up and kept ready, so that the other system, when it's taken down, the backup systems take over. And finally, extend the equipment life, right? The fact is, we are talking about some of the equipments in industries, let's say in energy generation, a device or a plant would cost close to about $1 billion plus. That being the case, the constituent of all the devices in that plant, if their life is extended by even a fraction of 1% to 2%, that itself is actually the revenue of most of the small companies in India at this point in time. So that being the case, IoT has a genesis of an industry or as an offering was brought in to finally address all of these possibilities, very specifically increase productivity of either the system or the device or the plant or the organization or the purpose itself. Taking it slightly ahead and trying to narrow it down to one industry, which I always liked from my very old days in IBM, in the automotive industry. Ford was one of the customers which used to work as service level systems engineers. So IoT is a process by which each aspect of an automobile, when I say automobile, it could be as simple as a electric motorbike, or for that matter, a 16 rig truck that actually is moving across the US geography, or for that matter, cross geographical movement of automotive, just for the purpose of pleasure travel or leisure travel. At any point in time, having sensors, having devices, having specific aspects of the performance or the wear and tear of the specific, let's say tires for that matter, or let's say oil pressure, or when it comes to either the clutch or the brake pads for that matter, or for that matter, just the ambient heat inside the cabin, or the ambient heat inside the engine of an automotive. All of those things, which were all manually sensed about 20-25 years back. Now, last decade, everything has been digitized, and most of you know this already. Nowadays, very rarely you will see a spanner and a screwdriver as a weapon of, or a choice of instrument by a mechanic nowadays. Nowadays, most of the mechanics carry a iPad, which has got a multi-sensory cable, which they take it and open our hood of the automotive, plug into the computer's when I say computer, that's the key part, right? They actually plug into the computer in our audio, in our automobile, and then understand what's happened. And now this is when there is physical connectivity. Now, if you actually extend that, saying as the vehicle is running, how would we able to transfer this set of data or all of this data? And if we are able to real time share this data with different involved or different interested parties. When we say interested parties, it could be to the manufacturer, it could be to the service provider, it could be to the insurance organization, it could be to the spare parts available on the road, or it could be for the fuel pump operator in the journey that you are taken. If all of this data could actually be prepped real time and shared, that is the kind of opportunity that IoT has created in the last decade plus. And from being in R&D, most of this has now already come into a commercial existence. And to my knowledge, Europe pretty much is now the leader in the space of IoT centric devices in the automotive space. I'm going to show you three slides of the same content. It'll be interesting to know. The first slide is from a research boutique research organization, which a long time back predicted saying by 2020 there will be 8 billion devices that would be, and there's a disclaimer, not using mobile phones, right? So there will be 8 billion devices that will actually be in use in the business models, which means they would be either connected to each other or by themselves sharing some amount of data and serving a purpose. Now, hold on to this thought. We're talking about 8 billion devices in 2020, in 2014. Then, sometime back, there was 2010 one 12.5, which means in 2015, it was actually 25 billion as a prediction by Cisco. And Cisco, as you know, is pretty much the leader in the space of connected devices now. And Cisco's prediction was that there will be a possibility of 50 billion devices connected. And this, in a way, also includes mobile because they also are network service providers for a lot of automotive as well as internet as well as mobility solutions. Now, the interesting aspect is in the same research report, there also was one small article to say in 2015 around where we're talking about matured markets, comparing India and comparing matured markets. They said there is anywhere between 5 to 10 connected devices in every house today. And we would be like, I mean, I would say, what do you mean 5 connected devices in my house? I know there is nothing like that. But then if you calmly look around the what you call living room that you are right now you got probably your TV turned on, then you've got a laptop, you've got a probably your Wi-Fi turned on, and probably your mobile is also turned on. Now, all of this could actually be interacting with one device, which could be your Wi-Fi or a repeater if your signal is low, or your mobile is connected to a data network on its own, which means by just the fact that we have spoken about a minute, we already have 4 connected devices in the house in India right now, which means if you take a exponential value of it in matured markets, this is cool. Possibility of 10 devices, yeah, we accept it. But then look at the ambition of Cisco. They're saying there will be 50 devices connected in a house. Now, most of you would have seen a lot of videos where we talk about there is a Alexa hub coming up, or there is a Google Home hub coming up. All of these are focusing not on aerospace or not on earth-shattering technologies. They actually are now converging to creating a unified home-centric connected device ecosystem. Now, hold on to the thought. We had 8 billion in the previous slide. Now we have 50 billion in the next slide, including mobile also. Now there is this data from IDC, which is one other boutique organization which puts out the data. And their point is the total number of available sensory objects, which is just not devices per se. They're talking about objects now. So which means now from the 2010 times 2014, 15 to 2020, now where we actually have matured to understand IoT per se is not about we create something for the purpose of transmitting data. What we understood is there are devices that were designed long time back before the word IoT itself was coined out. Those devices are also sensory and they also transmit something. Could be data, could be sensor, could be anything for that matter. Or that all put together, we're talking about 212 billion sensory objects in the world today, which means 8 to 50 to 212. This exponential growth is in the space of about 9 years from the same set of research organizations which do it every year for that matter. Now, why I said that before talking about what could be IoT, what is the transport layer, what is AI, what all of those things. Why? Because being a solutions leader, or for that matter, partly a successful entrepreneur, I always want to look at what is the business benefit that I'm giving to the the customer? What is the business that I can show or take it to the market? At the end of the day, any research requires money, and each money has to be returned back with an interest. That's how I've learned my lessons of having lost money in some of the ventures, but then made some money in other ventures, right? So if this is the kind of market that we're looking at, which means what could be the actual potential usage of this, commercial value of this, and from that, what's the revenue possibility? So I just leave the imagination to you now. I'll continue on. So I'm not going to get challenged about what is IoT per se. IoT per se is very simple. It's a collection of certain layers of information. Just give me 1 minute. Sorry, I'm still working, unfortunately. So I have to ensure my office phone is switched off. Sorry, for some time. So, okay. So what is a very simple high level framework of an IoT architecture, right? What is IoT, right? IoT is a thing. Engineers don't hit me saying how can you say what we create as a thing. But at the end of the day, that's how it is from architecture standpoint. It's defined. It's not just a thing. It could also be an intelligent device, and it need not be intelligent device static in one location per se. It could also be an edge device. The difference between a sensory device to an edge device to actually a meshable device or a SWAM device is all coming in the later part of the discussions. Gateways, right? So some sensors transmit data, some sensors don't transmit. You have to physically go to it to pick up the data. Like in the initial example I gave, you need to carry the iPad to the computer chip, computer array inside the car to be able to pick up the data. If not, if you want to actually transmit and push it out to a specific storage or a transmitter or a telecommunication network, then you use gateway. Network infrastructure, it's a coupling point from gateway to be able to transfer or transport the data either repeatedly or on a given frequency or on a given event in databases. Now, you would think about what do you mean database on an IoT, right? The fact is, whether there is database or not, every IoT device, or for that matter, every capacitor, transistor, or any specific IoT design-based thing that we create has been designed to have some storage. So databases could be anywhere between a 4 kilobyte storage to nowadays we are getting what would I say, Raspberry for anything not less than even GBs of data being stored in those devices, right? So databases are now a possibility, and device lean databases or what we call as distributed databases, those are all now actually a part of the IoT architecture. With its becoming more mature with the requirements and the demand coming from the various industry applications. Now, that's the second point, and the last point from a database to the applications point of view, where now with these enabling functions where it has got intelligence which can be built on top of, it can now transmit its information on a frequency or on demand, and it can actually do that over networks. Plus, it can actually store, if required, create intelligence to process that and take that across to be able to put that into an application storage or application infrastructure, from where the scale on which the same data, either from one device or a set of devices, can actually be brought together, analyzed, and then projected to the end consumers, is the overall architecture on which the IoT sensory devices or IoT process devices are created for. What we define from the connectivity stack perspective of an IoT is, by design, IoT is for two things. One is to sense certain information to where it is connected to, or to be able to provide that information through its layer across to the end through the transport layer, right? So we're talking about the physical device, which is where the things or the Internet of Things part come in. Then we also come from there to the next layer, which is the connectivity part of it. Could be intelligent or could be dumb. When I say dumb, it's direct cable to cable connectivity required, and aggregation of data and transformation of data. But that is where the gateway part comes in. So what we previously saw is something which we're putting in visual representation. Storage and access, which is where our part of the database, whether it is distributed data or lean data or light data, which is available within the device or available at the gateway or beyond the gateway into a cloud, all those possibilities as a layer. And on top of it, applications which use the data which is available from various devices for the purpose of the customers that they're serving. When I say purpose of customers they're serving, the same automobile data can be supplied to 3 different sets of customers. One, to the manufacturer saying what's the wear and tear of the automotive. Could be to the insurer saying what's the behavior of the driver. Could be to the spare parts or the services organization to say, this is now, do you know so much? This is now from a spare parts perspective or from actual parts perspective, you might want to actually give a call to the owner and then expedite the service date, or for that matter, remind them that the service date is coming up. Why? Because this is the current state of a specific part. So those are the various parts, but all of that will depend on the same data. It's just about how you represent that data to the different audience, right? And finally, value. Now, I'm sure most of you would have seen that video just floating around a few years back, where in which there is one insurance company of an automotive where they hit each other and then they wait for hours together for the actual inspector to come, and then the policy is shared with each other, and then it takes eons for them to get dragged back, towed back, and then get the replacement and stuff like that. And immediately after that, there's another thing where there is a drone where it's called on by the automotive owner or the automobile owner, and then the drone comes in, does an inspection, and on call real time, the whole thing is resolved, and both the parties who are involved in the accident just walk away happy. Now, that is what is the 6th level, as you put it, as a value that was provided with the same set of devices, but as different way of bringing together an ecosystem who at the end of the day makes the customer happy, resulting which even at a point in time you want to have 10% premium added to the insurance that the customer takes on you, they'll be happy because you actually save time and money for them when the actual incident happens. That's where the value proposition comes in. That's where most of us solution architects or business service providers where make a difference, understanding the underlying applications, systems under the architecture. Now, from the this is where we separate the physical world and the data world. Layers 1, 2, and 3 would have seen it's physical world. It's engineering. It's what would I say, hardware and network and component related. But then from the point of 4, 5, and 6 onwards, that's where the application part comes in. When I say application part, there is data. That's data that's getting generated across from these 3 layers, either collectively or by individual layer. But then take the data across and then be able to make sense out of it is where the layers 4, 5, 6 comes up. So some of it which I have spoken to you already, wherein which what is the data that I am carrying it back to the consumer as information at the end of the day. If I don't provide the information to the consumer, there is no point collecting the data, right? Just dumping the data on the consumer is of no value. So the idea is to create certain data models, create the right amount of data and the right data, and to be able to bring that together as contextual information so that the consumer now understands, okay, now the boiler plant that I have commissioned right now in my plant, let's say in Varagadam, that boiler plant was supposed to run for, let's say, 26 days continuously. Now, a sensory device says that it started on X date and now it's 24th day, which means that 24th day could be where I set an alarm to say, now send this, I am now on 24-day continuous to the, let's say the plant in charge, which is the maintenance officer or maintenance operator or maintenance lead. Why? Because it doesn't mean that at the day of 26, they should be aware to bring the fallback system so that this process continues. And this boiler plant now goes into maintenance. Why on 24th day? This could be again dependent on the individual business. But then what we have experienced is, let's say in Saint-Gobain's case, they have to ensure that there is a pre-work to create a maintenance work order for a given size of a boiler plant. So many hours that needs to be if there is a requirement of a part to be changed. It's not because warranted, it's just cyclical. So all of this required that the whole work order was automatically created, sent across to the maintenance in charge. And that person also sends the information in real time across to their service operator or service provider. And all of them gets notified that they assemble in the plant on the 26th day, so that the fallback system now goes on to the shift. It goes to run the next 26 days. And this plant, this boiler is now taken down for maintenance, and it is a specific number of days. Now, all of this is something which we would just assume that, hey, this is just regular work. What's the big deal about it? But the fact was, this all has been now done through sensory devices, originally with SCADA. Now we are actually migrating that SCADA to an IoT centric intelligent devices. This is the difference. That's currently the actual project that has been implemented in a couple of those large industries over there. Now, how this is because the sensor just gave data that I'm old so much, but then taking the data that has been running from first day to this day, and on the 24th day, triggering an alert saying that, no, take this, send this information to 4 different stakeholders, but the same data will go different to different stakeholders. To the maintenance operator, it just say, I'm in 24th day, please plan for the maintenance. To the service provider, it is going to say, I am so-and-so, I am so-and-so device, I am so-and-so, and this is my number of days that I worked so far. So based on that, whatever is the service provider who's to bring the right amount of person, right amount of equipments to be able to service the boiler plant has to come through. So that is another individual information. If for a reason there is a warrantor and there is a part that needs to be bought to be ordered for, then the vendor who is empaneled for that also has to be informed. All of this comes from the same data. So that difference between a data and information and propagation of the information to the different stakeholders is where the actual value proposition comes in, right? So having said that, there are various ways and means by which that data can actually be sent across in the network. The device itself, if it is built in that design, can transmit the data directly to the stakeholder, or it actually puts all the data to a gateway or a gateway-centric data source or cloud for that matter nowadays. And from the cloud, you can actually have applications to run on top of it. Or you can provide over-the-air applications, or OTAs as we call, wherein which from the device by certain communication protocols being enabled, the OTAs can directly speak to the specific stakeholder and inform them what needs to be, right? So the reason why we talk about transformation of data to information, most of which we spoke about previously, but the fact is, when we talk about data in the IT world, it's very cheap. Why? Because it's repetitive and it keeps continuously happening. But data in the industrial scale is never cheap, because that instance, that moment the part goes right or goes wrong cannot be repeated for the purpose like in the IT. We call about simulation. We talk about this bug cannot be repeated. Let's recreate the bug. We can't do that in the IoT world, right? I mean, all of you know that. If it's something is going wrong, it needs to be found at that point going wrong. You can't be saying, okay, let's see whether it actually breaks. That cannot be the whole purpose of this. The whole purpose of this whole IoT-centric business model, right? That's why we talk about data, right data at the right time, transformed into information on real time, and ensuring that the breakdown doesn't happen, but it's predicted or prescribed to the right people, right stakeholder. Now, all of this will also mean that in addition to the existing device from a manufacturer's perspective, sensors to be added to the on top of it is going to be a cost, and that cost of ownership will be multiplied by not just the sensory data, sensory device to be attached to it, how to collect the data, how to process the data, whom the data should go, what information is also going to be the total cost of ownership if you're looking at IoT-centric business model. I did not put to confuse you this slide, but to be very frank, this is just even a very, very small fraction of actual devices that actually are in existence today in the industry across the globe. I think somebody has just did a marking on this. Is this something which we can remove, or?
I don't know, sir. You continue that.
Okay, because it's going to be recorded. This is going to be a irritation for people seeing it. That's fine. Okay. Oh, I think people are having fun in the evening, right? So, okay, fine. So these are all some of the different protocols that currently are being used right now. Are we going to do something about it, or we just leave it there, the scratches?
Just to continue that.
Okay, no problem. I don't have any challenge on that. So
Continue, sir.
some of this protocols, some of these keywords or technologies or what we call as infrastructure are all just a fraction of what's currently being used in different parts of the industries as well as across the world, right? The traditional model has always been client-server models, where there is always a master-slave approach or a client-server approach, wherein which they have lots of clients connected to a server, and hence there are a lot of overheads, congestions, and each client will have to have its own inherent knowledge, inherent intelligence, and to be able to uh, update or upgrade even a client or set of clients was always going to be very, very challenging and costly exercise per se. And deriving a combined data or a collaborative data from these devices or these clients across to a server and then to the consumer is always going to be a second set of multiple challenges across. Now, that something gets changed in looking at IoT as the protocol or IoT as the opportunity here, right? All of us know that IoTs are pretty much at the point of sensory, it's going to be messaging architecture. It is either going to be publishing itself, whatever the data that is got, or if there are repeaters or devices that actually not just publish, they also subscribe to it if they are into edge devices or meshing or SWAM devices. In that being the case, not only that they store and transmit their sensory data, they also from the nearby devices collect data. Why is this PubSub kind of a device being designed per se? Because it reduces again the cost of investment and cost of ownership. Let's say we are in an agriculture field, and let's say we talk about for a given acreage, which actually currently in use in one of the friends plant in Hosur. Given acreage for 1 acre, the friend of mine needs to have 16 devices connected to be able to provide what is the atmospheric count or what is the humidity that's available, and resulting based on that at a certain point in time the drip irrigation starts automatically. Now for him to be able to put this kind of a device on all 16 of them that he has to invest, it was quite costly, and that is where being from Infosys, these guys came up with a concept where why do it for all 16? Why didn't we come up with a PubSub model where one of the four will actually have this subscription model also, where the other three will publish the data to, and one device would actually be the hub and spoke, and from that hub it will actually transmit directly to the other hub or to the central storage available within the townhouse. That was a model where it was very, very positive, where they're able to cut their cost from where it was like close to about 2.5 to 3 lakhs for per acre of per acre of investment to less than about 60,000 rupees. That's a huge difference, resulting which one, their investment came down, and their also utilization of water and irrigation also was quite optimal at that point in time. Why I mentioned MQTT, I mean, most of you already know that the MQTT one was the most secure and most used, widely used protocol nowadays. I'm sure some of you know about the uh, biggest and most powerful messaging tool right now, which actually uses MQTT as its foundational protocol, and that's not WhatsApp. Overlay networks. Overlay networks is very interesting for us. The reason because overlay is something where it doesn't disturb the existing investments being made in assets, and even for that matter networks. It actually sits on top of it, and it just kind of creates a meshing model wherein which it allows the existing sensors to be utilized, to be brought into an informational network. And just by the way of their overlay design or meshing design, they ensure that the sensory devices data and the concept I told about the repeater and subscriber model, between them, they're able to pick up the right amount of data on a given frequency and push it across to the gateways and the data storages or the data lakes for that matter. And from there, they're able to push all the data to an enterprise information model. And from there, convert the data to reports, analytics, and publish that across to the various audience within their enterprise. I'm not going to explain this because pretty much what we spoke in the last 3 slides is what actually we have put on a visual representation from an overlay diagram perspective. But just to highlight, the overlay network architecture is slightly much more optimal compared to from ground up designing the entire infrastructure of IoT to be able to speak to each other. So it takes into account the existing investments made even in legacy systems also, like SCADA, as compared to the industrial IoT devices. Now, more than the inherent industrial network of IoT devices, industrial information network or enterprise systems, the partner ecosystems are much more important per se. Now, going back to the same automotive model, what I have kind of shared is the ecosystem is what makes it interesting. The same data of one car and the driver and the sum of the car. When I say sum of the car, it's parts, it's tires, it's brakes, it's engine, it's everything of that. All the data goes across to the various stakeholders, various ecosystem partners, and each of them analyze it for their purpose of it. And that's where the partner ecosystem is important. There is no need for all of them to be able to swam around the same car. Rather, they wait for that data that is required for them, or all the data gets pulled through an OTA over the air app from the car across to a storage on the cloud, maybe hosted by the automotive manufacturer or service provider. And then these ecosystem partners kind of come together on that cloud storage of the data lake, and from there pick data and convert that into reports or analytics that they want, and then come back to either the manufacturer or the service provider or the customer itself, who's the driver per se, and then go about their business. That ecosystem is something which makes IoT much more viable and much more result oriented, and achieves a better return of investment over time of usage, over time of deployment, over time of usage. Disclaimer, we have partnerships from Ramco Systems with two of the biggest IoT device manufacturers in the globe. So coming into this, why is so much of interest happening in IoT today? And these snippets that I've kind of pulled together to provide it out is something to tell you that this has been a buzz going around for not now, probably a decade to my understanding, or probably even before that. 2009 is when I was first introduced to what we call as smart meters in Australia, from where one of the largest utilitarian companies in Australia, specifically South Australia, was completely replacing all analog meters to smart meters for the purpose of tracking the usage of three key utilities. One was gas, second was hot water, and the third was electricity. So this was something where using Oracle's enterprise solutions for information systems, customer support systems, that was something which was a first information for me to see what was a smart world to start with from IBM perspective. I mean, all of you know that smart is the word that pretty much was coined by IBM per se to deploy, and then smart city, which Singapore was the prototype, and it's currently still getting implemented on a continuous basis, is also IBM's research pilot. Now, that 2009, about a decade back, the concept of not having the need to actually go to a consumer's house or an office to be able to understand what's happening on all the utility that I, as energy utility provider, giving to the consumer, was something was laughed about to an extent. And then over 1.5 to 2 years, when this project was completed successfully, now that has become now the norm. And I think what's happening in India also is that even in the flat which I'm staying now in Bangalore, we're talking about smart water meters. What is basically to see what is the inflow of water that's happening just from the data perspective. Right now we're talking about meter devices, and subsequently these meter devices can be an intelligent device also going forward, which is what was there in the case of an Australian project. Now this 10 years back, and now it's going to get more interesting and more chit chat running the world on the IoT basis. Now, what could be the various industries, industrial applications, or fields, or verticals, or opportunities from an IoT perspective? Smart factory. I think most of us already know this case where the Fiat factory right now in India runs at a 15% human potential, human capacity, as against 100% of another manufacturer, which means the balance 85% of it is completely automated, robotized, and interconnected between themselves, so that the entire floor actually is filled with specific interconnected communicating devices, and the assembly line is manned only by X percentage of a human being at this point in time. Now, that is something which we know from automotive perspective, from an example, but we from Ramco has seen this happening in multiple other industries itself, industrial houses. One being our own parent company, Ramco Cements, or Ramco Industries, which actually caters to multiple industrial houses in manufacturing. Connected marketing. This is something which we can need not even worry about. So, I mean, again, about 15 years back, for that matter, we have talked about marketing when you are near a certain shop, right? Suddenly we will get a message saying, hey, why don't you come into my shop? I'm just about 100 meters from your place where you're walking by. And this used to happen where we used to have the Bluetooth enabled from our mobiles those days, near site marketing or ambient geo fenced marketing was something which was experimented. Now it's become a norm. I mean, like, if you go into a Starbucks today, you don't have to actually go find out what is the offer. The moment the Starbucks knows your mobile is on, it's you are inside the geofence. Automatically, the sense tells you that you are so and so. You have done so many purchases. You have so much of Starbucks points. You can now utilize that, and if you want, now I can have the person sent to your place where you are, which means not just the data about what you are, where you are sitting in Starbucks from a planogram perspective, that also is also available to the Starbucks. And this is something which we know for sure it's happening today in the world across the various Starbucks locations. And like that, so many other industrial processes, opportunities, and the fields where in which IoT is now becoming a default and an important constituent. Now, all that we spoke about, introducing IoT, introducing the opportunities, introducing this, finally comes back to the real dollars, right? And who better in the world to tell about, if you're talking about an opportunity, put a number on the opportunity, right? Than GE. Most of us know who GE is, General Electric company per se. General Electric is a group which practically is in every business, from its first business model, to my understanding, which is basically from oil to energy to agriculture to pesticides to anything and everything that GE has touched on it. And for that matter, GE's projection of what could be actually be an industrial Internet of Things or an IIoT from a realizable revenue or business benefit perspective is close to about $276 billion. And this is just 2 years back. When they said this 2 years back, at the time, the expected growth of the world per se was actually in a negative, because we are actually in the degrowth stage. 2020, now if the corona did not happen, assuming, then this would actually started growing. Now, what is the impact of corona per se? What's the impact of COVID-19 and the lockdown and on the economy is something which none of the models have ever understood, ever expected. Now, there are models being projected from a theoretical perspective, but we really need to know that 2 years back, $276 billion, it's a huge number to put on probably 50 billion devices generating that revenue, right? And that too from one industrial house perspective. If you take that and let me apply this as an exponential model of, let's say, 10 industrial organizations across the globe, we're talking about a minimum of a few $trillion of economy that can actually be expected in the next 10 to 15 years from just the concept of IoT and the data that the IoT devices generate. So why now? As I said, 15 years back, 20 years back, even 10 years back, from my experience itself, things from metered devices to smart devices actually started. Why now? Why is this kind of storming up or brewing up to say, okay, let's do it now kind of stuff? cost of adding devices has come down drastically. When we say cost of adding devices, the concept of cloud and the connectivity and locally available resources of devices to be able to create. And even interestingly, one more new technology which is added to the advantage to is this 3D graphics or 3D printing. That also has made a big advantage in this area. More important than the cloud API economy. When we talk about connected systems and ecosystems of partners coming together, not one company is going to write what all of us should do, which was those days where somebody wrote what is the process and there was a standard driven approach and each of them had to contribute to the standard in the same way across the entire process. Now that is broken down to only what area I am interested in. If I'm a service provider, I will look at only information that I need and then what information I will provide, which means there is a sequence of handoffs of data from the manufacturer till the tire puncture shop owner, wherein which different sets of data is going to be required. And for that, each of them, if they have to participate in this economy, for them to be able to connect to this network is by way of APIs. And I'm sure most of you already know what's the power of API. Ramco is big in API because not only we are an enterprise solutions provider, we also have partnerships or integrations to various global solutions because the clients of ours are global clients and they have different legacy systems, homegrown systems, or other enterprise solutions which you have to integrate into. And the best and the most optimal ways to do through the APIs. And in IoT, even more important that we do it such a way that each of us know what we want to publish or what we want to consume from a subscription perspective, and hence ask the other service provider saying that this is what I need, so give me the data exchange or information exchange through APIs. Big data analytics, in my perspective, this has been going around for nearly 30 to 35 years, what we call as analytics in various forms and shapes. Now we call it as data science, and I don't know what they'll call in the future, but data at the end of the day, getting transferred to usable information is what is the underlying information. AI, we are still figuring out what is AI. I'm actually a research scientist now, getting into my PhD, and probably I would have scratched the surface about understanding what AI is, and that through only through a few statistical models that we have understood. The reason why, because AI today is limited by human being, folks like me. I designed a system thinking it's going to be artificially intelligent, but then that's limited to the statistical models, rules, procedures, boundary conditions, and information that I provide to that system to think. The moment I say you think, which means there has to be no boundary condition, but then right at this point, we are limited by our device and our design of what AI is. But I think that will grow, and that's actually growing. All of us are waiting for the breakthrough on quantum computing per se. Once that qubits are able to now go beyond this binary concept of the world of then stay in non-binary world where possibilities become actually information and that could be processed. That's probably where we feel AI could actually evolve. Let's wait and see. Robotics have become more and more intelligent now. They are ambient. They sense what's their surroundings. They're able to react to their surroundings. They don't do mechanical repetitive work again and again. Rather, they're able to react, understand, adapt, and that's something which is also happening now. All of these various elements actually brings this concept of IoT and its business opportunities today to be taken into the actual realization phase. I'm sure every one of us have at least one smart watch or one smart band or something that is there in our house in various forms and shapes. And we also have probably a smart bulb now. We talk about a specific type of bulb can have better life than another type of bulb. And that's because not because of anything else. It's the same electricity, it's the same house it's generating, but the fact is the way it's designed to absorb the same amount of current, but then provide a different ambient, different, for no other word, light, uh, and be able to provide that in a longer duration makes it either smart or optimal. That's how the whole world is changing towards. I talked about API economy. This is the one thing which, if you are in the IoT ecosystem, if you don't have API as part of your enabling infrastructure, then you will not come to the game at all of IoT. So two different pictures. There is the petrol pump, or there's a fuel station, and there is the jewelry shop. Now, how are these two connected in what form and shape, right? Uh, we can simply say that, hey, the same customer who is going to the fuel shop also comes to the jewelry shop, and that's the very outside in view of what's the common between these two pictures at the end of the day, right? But let's see, it's not just that, it's about the intelligence. The intelligence being, uh, the fuel pump knows that, Jack, I have a certain type of a car. I used to go on, let's say, a Honda Accord, and I used to use the regular fuel, and I used to put specific amount of fuel every time. I never top up the tank, as we call, right? Which means I was living within a certain what we call as commercial conditions, or income capacity that I used to have. Now, suddenly, last five occurrences of the same fuel pump, I go there, I don't go on a Honda Accord, let's say I go on a Mercedes Maybach, or let's say I go on a BMW 5 Series. How? Because the fuel pump knows that I'm actually now on the BMW, because it's connected by devices. Assume this is the ecosystem. Now, not only that, I go on a BMW 5 Series, I now actually top up my tank every time I go. I don't really care about specific set of fuel quantity I put over there. And not only that, I actually go around, buy more stuff in the shop connected to the fuel store. Now, previous world, when I was within a specific income capacity, when I go to the jewelry shop, the jewelry shop, because they are connected world, told the jewelry shopkeeper, this is so and so with income potential, and this is the habit. And next time when I go, when I'm in this BMW world, when I go, the same shopkeeper, if the information is available to the shopkeeper, they're going to come up and not just show me probably gold, but probably they're going to show platinum to me. And from platinum, they're going to not just show platinum, they're going to show excessive jewelry, which I don't want really, or might not have come to even actually buy. Now, why is that? Because the other behavior that I never used to get out of my car in the Honda Accord world, but in BMW world, I go out and buy whatever I want, just spend more money on the fuel station, means that I'm a spender, not a buyer per se. Difference being, buyer goes with specific purpose, spender just spends whatever that they see as more an impact or an impulse purchase. Now, that is what we call as intelligence. Now, this intelligence is the difference, that is the world that connects the various devices, data coming from the same environment, same set of instruments, same set of devices, but then make sense out of it by an intelligent system, which pushes this data into different buckets and presents that in different forms and shapes to the various stakeholders. Right? And these are all the various ways by which this could actually happen from an implementation perspective. I'm sure most of you have heard about swarm intelligence. Sorry. I think recently, about 3-4 days back, was one of the avid work from home friend of mine posted a set of birds coming back home, and it was exactly in the same fashion that you're seeing on the right side third, where the specific bird flocks, as if it's in a lambda or an infinity loop per se, when they go back to their, typically at the end of it, it's a swarm intelligence, right? Which means each bird in that swarm actually was following the other bird or the other bird or the other bird, but collectively they had intelligence to go from point A to point B. That is, they had intelligence collectively to go from where they were searching for food to be able to go back home. That's the ultimate information, where how do I don't have to instill intelligence in all of the devices that is there deployed. Rather, how can I sparingly utilize this PubSub model or swarm intelligence model to be able to make each device do its part or react to the requirement from the other device that actually has done a certain activity. I'm just diluting it down to so that it's easy for us to understand between us, right? And of course, this is enabled by you engineers. Initially, I said I'm not an engineer per se. Just use the information and then try to make sense out of it from a business perspective. How this is stored, how is this converted to data, and how is it transmitted, all comes from the access and sensors. I don't want to go detail into it, but some of the similar models where in which we have various layers of from the edge or what we call as from the external or the sensory world of, let's say, an automotive, from then across to command center or a cloud storage or an application command control, how the data actually moves across. And the various companies on the top, SAP, Ariba, Yada, they're all major players in the concept of each layer. Cisco and Motorola, and for that matter, even BMW is one of the leaders in the edge computing world, specifically in the OTA space. So we all talked about data a lot, and we talked very specifically about information per se, right? Now that is the key representation of the slide here. We're talking about AI, and AI to an extent is about deriving intelligence from the noise that is around data, right? The function of converting a set of data to a specific requirement for the stakeholder is what is intelligence. Artificial intelligence, will come back to it later, but deriving intelligence of noise is what we call as a function of X, or function of a set of architecture or an application or a simple extraction of data from a data lake. That is what creates the first step of intelligence. And from then on, being able to combine this set of information from the data and provide it as a report for repetitive distribution or as an analysis, provide a further business value driven analytics to a consumer or to an industrial body, or to, even for that matter, IEI's TNSC, over a period of time, knowing that so much seminars have happened using a certain instrument or certain communication protocol like Zoom, rather than that data being available instead of Zoom, for so much of cost that I've incurred on doing it. If I have to use it a different platform, what will be the cost of it? That analytics part of it, getting the value, and then basis, you'll be able to decide what's going to be your next purchasing power, or what's going to be your next operating model, is something where is the function, and that is driven by intelligence, right? Artificial, the concept of, I'm sure most of you understand, the recency and frequency is the most repeatedly used artificial, or rather intuitive model, where in which if let's say you go to Google, the concept of cookies that they put out on the browsers, they know exactly how many or what pages that you keep repeatedly visiting, and that kind of goes by the frequency part of it. And then what was the last recent page that you visited from a recency point of view? So recency frequencies is the first step of getting into creating some artificial decision models, which is the artificial intelligence to start with, and then that kind of goes into a future where I'm also personally studying on, is neural networks, where it starts coming from this simple recency frequency to prescriptive to predictive to actually completely AI-centric models, where we can decide on the fly, if I have to sell a barrel of oil in a given location. Let's say I have capacity to trade barrels of oil. How can I, from the point of my production, either increase the throughput of the oil field, or rather tone it down, or cap the whole oil pump itself, the oil well itself? All can be decided based on what information I use to sell that barrel of oil, or what information I have in the trading market I get for the barrel of oil. So if you can look at it, the kind of vast potential, where what's being traded, and to that directly have an impact of to be able to cap a oil well, or tone it down, or for that matter increase the productivity, is how the whole concept of an IoT to an AI can be combined into. And why I said oil, because that's the most talked about in the current COVID capacity, where practically less than 5% of the automobiles or consumption of oil is happening, or fossil fuel is happening per se. Hence, the US oil is kind of now in negative capacity, not even positive capacity, meaning it's actually paying money to produce oil rather than actually the other way around, where you're supposed to pay money to buy fuel. That's where it is right now. Right? Okay. So I've spoken a lot about this. What's the opportunity, and what's the role of big data per se? And the moment you have enough data, and applying statistical models on top of the big data, or data per se as data lake as we call it, from then on, going on to AI is where the actual value can be derived from the various IoT device-centric information that's coming from the data and the sensory devices. So from now on, I'll be going slightly faster. Some of the models that we spoke about is, sorry. So just representative models that I'm talking about, we want to apply AI on top of what kind of a data set. If you want using image and sound, then we're looking at CNN models, which is convolutional neural networks. And we're talking about transactional data sequences. We're talking about long short-term LSTMs, which means at a certain point in time, we pick up a set of data, create the next layer of prediction, and then from then we forget the previous layer, and then from then on goes. That's the kind of models. Text NLPs, I think most of you heard about NLP servers, NLP models nowadays. And behavior reinforcement learning, right? Reinforcement learning is very important, specifically in the automotive sector today, very directly connected to the insurance premiums that's currently being used currently, I think it's already in use in Europe as well as the Russian markets, Russian automotive markets, right? On heavy industries, from a manufacturing or a marketing or sales perspective, prediction models or event interpolations or churns or cross-selling, upselling, if you're using a marketing tool or if you're using a sales tool, how to get what data point. Like we said, what's the common factor between fuel pump data to a jewelry pump data? That's where the cross-selling, upselling models come into effect if you properly utilize the statistical models. These are all the real world examples of what could be the use of AI in IoT per se. I'm sure because you're recording it, when you have time, you can actually play it back and then go through that. But one point is the fitness and health tracking as a wearable information. That's something that's already now realized. Now we are now looking at connected fitness bands. Now people have started giving you saying, okay, you, Jack, had walked 10,000 steps. Now your friend who's also in the same device walked 12,000 steps. Do you want me to connect to the both of you so we can create a competition? That's now becoming a reality already. I'm sure most of you are doing it. And could be somebody who's a friend, which I've accepted, or it could be my data goes to the cloud in say in Samsung. And Samsung now gives top 10 people who are walking more steps and then says, hey, 5 of you seem to be walking a lot. Why don't you guys get together? So there is so much opportunity that can happen just by the sheer factor of device data being pulled into a cloud, and then that analytics and working on top of that, creating an ecosystem. And hence it could be a viable business model or just a social intersection platform also. Healthcare is the most appreciative, most required industry, which is going to use this now as we speak. COVID-19, there are innumerable models of artificial intelligence from the various data that's coming out from the field. Every university of any quality in the world today is churning out so much of data. And I'm connected to at least 2 or 3 of the universities, couple of them in one in Singapore, one in Australia, and one in the US. We're able to find out to the fact that there was some kind of data that said certain type of blood groups are more resistant. Certain types of people at a certain age that they actually had put certain boosters as kids before 2 years. All those data points actually has started coming true now. The recovery percentages that we see in various countries in matured markets as against in growing markets like India or Southeast Asian markets per se, those data points are now getting actually being true. So that's something which is very important because good for us, I mean, bad for the humanity per se, but good for us that this happened so that we understand from it, design systems around it now from a COVID perspective, so that next, when the situation, God forbid, should not happen, we are more than ready to take care of that, encounter that, and actually eradicate it much faster with a connected network and information sharing model. I don't want to spend too much time on this, talking about this. Again, disclaimer, we have a smart port asset management already in use in one of the Southeast Asian countries from Ramco Systems. And we are also collaborating with Singapore government on smart city initiatives also. Specifically, I'll give you one of the examples as use case in the next few slides. This is just one slide. I want to take about a couple of more minutes. Blockchain and IoT, or blockchain and AI, that's something which been a very, very close to heart topic for me. I'm not sure how much of people understand what's a distributed ledger per se, but what I will say is that in the network of 5 different users, let's say Again, you'll go back to the same automobile example. The manufacturer does not know who is the actual driver after the second, third purchase. And the driver, the manufacturer's certified service provider might not be the third owner of the vehicle who's going to the service provider. Similarly, the spare parts may not be from a registered spare parts provider of the manufacturer, which means now after second or a third rotational sale of the car, there is a disconnected system, no disconnected ecosystem. But then can all of this brought into a hosted shared ledger or a distributed ledger where the car on its own, if it has a capacity to then transmit data and not to the manufacturer only or not to the trusted source of the manufacturer certified service provider, the service provider certified spare parts manufacturer and so on. So instead, I as the driver or the owner of the car can decide to say, let me participate in something called JACnet blockchain. And JACnet blockchain is an independent trustless system where all the data from the car and the driver's behavior gets pulled over there. And now Ford can, in addition to its trusted ecosystem of distributors, spare parts providers and all, yada, can also connect to JACnet and then find out what's happening to my car, which I manufactured 15 years back, 20 years back. What's the data it's providing? Who's consuming that data? Same can now be, forget Ford, let's say Maruti service provider who does agnostic service to all manufacturing and Maruti service or TVS service for that matter, services all cars, right? So TVS now not only connected to its partners like Maruti, let's say Ford, it also connects to JACnet and it knows now based on the TVS value service partner can now offer the driver at a discount more than what it used to offer to the other connected partners. So this is what I'm talking about, where a database which is shared, not owned by one organization or one set of people, it's shared by I as a driver or my car and the driver data, or all the people who are in this ecosystem own a piece of the data and they share that. So the shared economy model, as we call this Uber world or the other worlds on shared economy, is something which fundamentally can only be designed and delivered by the blockchain. And if we take that, extrapolate that to the devices and its intelligence, and on top of that, the data and information we can extract from this shared ledger, in my perspective, personal perspective, that's going to be the utopian. Let's see wherein how it happens, right? As I said, the challenges we have in the adoption of IoT is limited to what we have designed or what we assume or what we create per se. The more and more people collaborate, the expansion or the adoption can actually be exponentially faster and then bigger. Roadmap of IoT per se, the concept of IoT should, to kind of reduce it, should not be assumed to be all brought into the device itself and making it too bulky or too thick. Rather, keep it to what needs to be, make it serve its purpose, and then connect it using overlay networks so that you can start adopting an IoT or IoT-centric ecosystem immediately. And then from then on, and different layers to be able to either add more capacity of devices or add more capacity in the overlay network, such a way that there's a business value that's coming out of it. I'll skip this part. I'm just going to go only one example, which currently, as I said, it's a disclaimer. This is Ramco Systems R&D output, R&D labs output per se. Reacting to the COVID-19 situation, Ramco Systems has actually already implemented this, and there is a global reach out to various large organizations wherein which during the lockdown and once the lockdown gets relaxed, there are going to be implementations of these solutions across the world. This is again the fear, uncertainty, and the kind of depression that we're going through across the world. I mean, I was told yesterday, looking at one of the statistical models, out of 240 habited countries in the world, 215 countries actually have COVID, and it was like zapped. And that now has become the new norm, which means if yet a virus called COVID can actually go to 215 countries per se, you cannot now stop it. It's only about how we actually can react to it or encounter it and then kind of come over it from a collected or a collaborative network. I'm sure most of you will have all the statistical data, and lockdown, right? So what I heard is I was assuming that each country is going to start opening up, but then I got to know 2 days back, France is completely locking down its country for another 2 more months, which was quite a surprise. So what's happening is that most of the organizations right now are looking at a touchless employee experience. We need to touchless employee experience. Right now, every employee experience today is touch, from the point of your card systems or your instruments, which lets you in, lets you out, that recognizes you, or for that matter, a sweep or a scan. Everything actually is touch based at this point in time. Now, what the whole world is looking for is a touchless experience. Example, this is a touch where now 95% of every biometric device, which was the rule of the roost sometime back, because of the COVID situation, has become now the biggest point of failure, or biggest point of risk for any organization which is of any scale. Plastic, it's been proven that even COVID, from a Singapore government data perspective, stays live for about 3 days in the plastic. You can't screen beyond a certain point, right? Even the thermal scanning that was done in the airport has not made any big benefit for countries like India, for that matter, Malaysia, Singapore, for that matter. Systems where they are not intelligent, they are manual, even though they might lock and unlock, but you still have to interact with those edge systems or doors or things that let you, or you have to get in and get out. This is a projection. The example this was given, not from us, it from an industrial body, in which they had a thousand member in one shift, and one person affected at the point of the second or the third biometric scan, which means in the 30 days, practically 50% of their shift capacity is down because of the infection possibility. Now, we as Ramco launched some time back a facial recognition software, and that being part of the organization entry systems. So let me just run that quickly through a video. It's just a few minutes. And this is again 3.5 years back, which went into production, and it's there in some of large industrial houses in Middle East and in APAC countries. So it recognizes somebody who is registered in the system, but you still can see that they have to interact with the door and the devices to be able to go in. And then there is one another associate of mine who comes in, not recognized, and then the person has to physically interact the system to recognize themselves and stuff like that, right? Now, let's take the other one, which now we have gone on to introduce in the market, and that's waiting for the lockdown to be taken off so that we can start implementing globally, very specifically in the North American markets as well as the Asian American markets, Asian Pacific markets, right? Thermal scanning, we're talking about narrow scanning thermal as well as wide area scan. When I talk about narrow scanning, is somebody who is coming to the scanning device or scanning instrument and then projecting or providing themselves to, so that based on the device calibration, it tells that person to be allowed to enter the premise to be able to work or not based on the calibration being done, and that too the gate devices are completely IoT and edge enabled, resulting which there is zero touch required for a person who is assumed or who's calibrated and identified to be allowed to enter the premise to be able to continue to their work. Now, this could be for, as I said, a narrow scan or wide area scan, where in which we are looking at not only the person, but let's say in a given planogram of an office environment or in a given environment of a location, it does a wide area scan by which it finds out between 15 people available in that given spot or given geolocation, how much of the social distancing, what we call as 1 meter, 2 meter, 3 meter, whichever you calibrate again, is actually active, meaning 15 people, of that the ratio is that the social distancing of 1 meter is not being properly implemented because they are very close to each other. Well, that's another wide area scan. So narrow scanning about individual, wide area scan about a cluster of people. Those are all opportunities. That's something which we're now addressing now in the next upcoming solution. All of this again enabled through actual implementation of AI on top of IoT device data. also recognizes voice, which creates another opportunity for folks to actually not have to experience the touch or actually experience a touchless system now. Don't have to get into touch or anything that is possibility of a contamination model.
Hello, Guy. Please mark my attendance.
That's it. Based on the recognition of the voice as well as the other ambient data and the schedule and the what we call as the shift data, automatically the process and the person and the timesheet gets booked in this case. Right? So now this is the actual going forward implementation, wherein which we're talking about scans in specific entry points, and we're talking about scans which are completely going to be touchless, where devices by their design will actually interact with the calibrated data systems, and accordingly they will operate, resulting which a complete seamless touchless experience is what's coming out, and it's already now in the pipeline for implementation globally from Ramco Systems. So that's where I am at this point. I'm not sure, am I on time or am I late or I'm ahead, Praveen or Mr. Ramdas?
I think we should allow for some questions and then see if we have time.
Okay, I'll just leave it in the last slide. This is the business benefit that we project from a simple IoT device and a data on top of it, which we call as AI ML platform of Ramco. I'll leave this slide here as the last slide. I have one more use case, but I'll just not show that. That's more industrial, IoT centric industrial output, which in a way I spoke about it as the boiler plant capacity, wear and tear, and its maintenance work order life cycle. So I'm open to questions now.
Yeah. Any questions?
Can ask. Dr. Bala, can you?
Yes, Bala, go ahead.
Hi, sir.
Yes. What's
Sir,
your
actually, for me, one doubt, sir. In IoT, what about the security for data, sir? How the data is secured? That means, is there any hacking will be done? How the data will be protected from while fetching to the cloud? All the data, sir.
Right. So you know that, right? At the point of origin, we could actually secure the data at the device itself by making the data itself as non-readable data. And similarly, when you are transmitting data from using meshing, wherein which from one device to the edge system, and from then across to the gateway, data can be completely secure by different protocols. Once the device is able to transmit data, after that, the current typical telemetry or telephonic or internet enabled protocols can be used to secure the data.
Okay. Is there any software used for that one, sir?
Software at the device you're talking about, or software at large during the transmission of data?
Yes, sir. During large transmission of data.
There are multiple. Depends on the manufacturer. Let's say,
Okay.
example, we have started working with, as I said, Motorola, and we started working with our other partners, wherein which Honeywell is our global partner. So we have provided specific protocols which are to be used doing this, and hence, remember we talked about the API framework and the API offering. That will make a big difference to us going forward, to ensuring that the API can be now for the purpose of securing data over the distances from point A to point B.
Okay. And then one more doubt for me, can you please explain as simple in blockchain, sir? What is a blockchain and how the difference between blockchain and IoT, sir?
It's a very different topic.
Okay.
My email ID as well as my contact points in LinkedIn is available. Let's take it offline. That's going to be it's a close to my heart discussion point. We'll do it offline.
Sure, sir. Okay. Okay, sir. Thank you.
Hello.
Yes, please.
Sir, could you please tell me about that blockchain and IoT, the future of it, and in the industry perspectives, and what level the project is going on in IoT related blockchain based projects?
Okay, so to my knowledge, other than my own project implemented in Middle East, there are projects coming up in trade finance systems in against in APAC region. Again, wherein which let me stop sharing. I think there is no point. I'll just continue on the audio if that's okay with you. What I was saying is that there are industry level pilots that's already going on right now. MySec is something as an organization which most of you know is it's a global logistics provider, and they already have IoT and blockchain centric solutions, wherein which they take a product in a container. See, Maersk owns shipping lines and containers, right? They don't own the product inside. They only transport that. But their containers and their shipping lines talk to the various partners in the ecosystem. One central location, and from that to be communicating to the various ports. That's why one of the use cases which I shared to you was smart ports in the IoT use case model, and subsequently from then to also the folks who are actually transporting those products. This means the folks can understand and trust each other, or they can say, I don't trust the other person. And the whole trade finance system was brought in saying that the producer and the buyer in two different regions did not trust each other, and hence they needed a bank to come in between. This shipping line and logistics is an industry which is already experimenting, where they're cutting the middleman and using the distributed ledger for all the ecosystem partners to write their set of data. And that is also contributed by the containers and shipping line IoT devices. It's already happening.
Blockchain based
Sorry?
academics.
I didn't get the question.
And I would like to know, we want to implement in the simulation based in blockchain. Is it possible to do simulation in a blockchain and verify the section benefits and all those things?
So, I mean, I would rather direct this to Praveen. He's actually a far more experienced person than me in blockchain. My experience in blockchain is very limited to what project I implemented. Praveen is a wealth of information. I would rather redirect you to be able to associate with Praveen to do all your simulations, and he will probably have multiple opportunities for you.
Mr. Raju,
yes, sir.
Please send mail to Chairman sir, and we will take it forward from there.
Okay, sir. Okay. Thank you, sir. Thank you. Thank you.
If there's not much questions, I mean, we can probably break off for the session today.
Yes, sir. Praveen?
Thanks, Jack. Thanks a lot for the very wonderful session. Though it's not a 1 hour session, you really packed a lot of information and showed a lot of perspective from the industry side. And from the industry side, we rarely get such a large perspective, Jack. Thank you so much from Institute of Engineers side. And we would like to have you for furthermore the next few things whenever your time permits, and a nice topic if you can give us. I would like to have you again back to the same forum, maybe in June sometime. Thank you very much, Jack.
Would love to, and thank you for having me and be patiently listening to what I was having. Thank you.
Yeah, if you can share the PPT with us in the email, that'll be great, sir.
I won't be able to because it's proprietary to Ramco per se, but then I have to do with the recording. Praveen, I'm sorry for that.
Okay, I got it. Thank you.
Thank you. Thank you all.
Thank you so.
Thank you.
Thank you.
Praveen?
Yeah.
Say about that IEI TNSC regularly doing some this type of kind of meetings and all those things.
Yeah, actually, Jack dropped out, I think.
Okay, no problem. Leave it.
Jack dropped.
Okay, sir. Thank you so much, Praveen sir, for a wonderful session. It was the most interactive session and industry specific, and it is also need of the hour. So the people would be thronging for this actually, and actually IEI TNSC alone can make it out again and again with a perfect speaker and a perfect topic on the table. And and Praveen sir, thank you so much for bringing him for a wonderful session here. Maybe the short session. By next month, whatever we are planning for a big workshop that would add value to all those speakers who are in the pipeline. So people can watch all these videos in YouTube, as sir said. So everything is available in our YouTube channel. Subscribe to this channel and also make sure.
Kindly subscribe that IEI Tamil Nadu
State Center.
Tamil Nadu State Center. The YouTube channel is there. Entire recorded will be available in the YouTube channel. You can everybody can view that, and then subscribe that. Bala, with this we close it.
Yes, sir. We can close it, sir. Thank you so much,
Bala.
sir. Thank you.
Thank you,
Thank you, sir. Thank you so
Good night.
much.
Good night, all.
Thank you. Welcome.